To return humans to the moon, the Artemis program has 4 main components: the Space Launch System, the Orion spacecraft, the Human Landing System, and Gateway. The Space Launch System, or SLS, is the most powerful rocket NASA has ever built. Its design, which is based off the Space Shuttle system, consists of a core stage built by Boeing, measuring 65 meters in length and 8.4 meters in diameter. It consists of a 2 million liter liquid hydrogen tank and 742,000 liter liquid oxygen tank, along with 4 Aerojet Rocketdyne RS-25 engines with a total sea level thrust of 7.4 meganewtons. To power the initial ascent, SLS has 2 5-stage solid rocket boosters attached to the core stage, measuring 54 meters in length and 3.7 meters in diameter. Built by Northrop Grumman, these boosters will burn for only 127 seconds, but will generate a combined thrust of 32 meganewtons, over 80% of SLS's total thrust at launch. Lastly, secured to the top of the core stage is the interim cryogenic propulsion stage, built by the United Launch Alliance. This second stage measures 13.7 meters in length and 5 meters in diameter. It contains liquid hydrogen and oxygen tanks, along with a 110 kilonewton Aerojet Rocketdyne RL-10 engine. Once in orbit, this engine will perform the translunar injection burn, boosting Orion from Earth towards the moon. This original SLS configuration, named Block 1, will be used for Artemis missions 1 through 3. For following missions though, Artemis will use a larger variant called SLS Block 1B, which will replace the interim cryogenic propulsion stage with the larger Exploration Upper Stage. Built by Boeing, the Exploration Upper Stage will have liquid oxygen and hydrogen tanks, along with 4 Aerojet Rocketdyne RL-10C3 engines, with a total thrust of 433 kilonewtons. This additional power will enable SLS to launch up to 42 metric tons into translunar injection, compared to 27 tons for the Block 1 variant. Eventually, Block 1B will then be upgraded to Block 2, which will use higher performance solid rocket boosters, enabling 46 tons of payload to be placed into translunar injection. The Orion spacecraft will carry astronauts to and from lunar orbit and consists of 2 sections. The first section is a 5-meter diameter, 3.3-meter tall habitable crew module, with space for 4 astronauts. Designed by Lockheed Martin, it has the same basic configuration as the Apollo Command and Service module, but with an increased diameter, an updated thermal protection system, and other modern technologies. Attached to the crew module is Orion's second section, the European Service Module. Designed by Airbus, it has a diameter and length of 4 meters and is equipped with 4 7-meter-long solar wings. It will provide power, propulsion, air, water, and thermal control for Orion, allowing it to support 4 astronauts for up to 21 days undocked and 6 months docked. Lastly, Orion is equipped with a launch abort system that will quickly eject the crew module away from the rest of the launch vehicle in the case of an emergency. While Orion will carry astronauts to lunar orbit, in order to land them on the surface, a Human Landing System, or HLS, is required. This is the equivalent to the lunar module from the Apollo missions. Rather than leading HLS development itself, in 2019, NASA asked industry leaders to develop their own HLS solutions and compete for a NASA contract. In November 2019, 5 companies submitted proposals. And in April 2020, 3 teams advanced to design contracts: the Blue Origin-led national team, SpaceX, and Dynetics. Then, on April 16, 2021, in a controversial decision, NASA selected only one design to move forward: SpaceX's Starship HLS system. Starship HLS, which is a variant of SpaceX's Starship, will have a length of 50 meters and diameter of 9 meters. It will be launched into orbit on a SpaceX Super Heavy booster. It will then be refueled by multiple Starship tankers before boosting itself into a lunar orbit. For Artemis 3, the Starship will rendezvous directly with Orion, whereas for Artemis 4, it will rendezvous with Gateway in preparation for the crew's arrival. After receiving the crews, Starship HLS will then descend to the lunar surface and stay for several days, before launching back into orbit. Finally, after returning the crew to Orion, it will dispose of itself by boosting into a heliocentric orbit. To ensure this process runs smoothly, Starship HLS will perform an uncrewed demo mission sometime in 2024. If successful, it will then be used for Artemis 3 and 4. However, only for these missions. For Artemis 5 and onwards, NASA has established the Lunar Exploration Transportation Services Program, or LETS, with the goal of developing a long-term sustainable lander solution. Blue Origin and Dynetics are now focusing their attention on the second contract with their Blue Moon and Dynetics HLS systems. SpaceX, on the other hand, is hopeful that Starship HLS will prove itself during Artemis 3 and 4, winning itself a contract extension. In order to establish a permanent human presence on the Moon, the Artemis program needs a staging ground to initiate and support surface operations. As a result, in 2017, NASA announced plans for Gateway, the world's first space station beyond low Earth orbit. The station, which will be placed in a near-rectilinear halo orbit around the Moon, will be able to adjust its orbit, enabling it to land and support astronauts all across the lunar surface. In order to achieve this, Gateway will be built in several stages. The initial configuration will consist of two elements: the Habitation and Logistics Outpost, or HALO, and the Power and Propulsion element. HALO, which is being built by Northrop Grumman, has a diameter of 3 meters and length of 6 meters. It will provide living and working spaces, in addition to ports for connecting with other elements. Meanwhile, the Power and Propulsion element, which is being built by Maxar Technologies, will generate 60 kilowatts of solar electron ion propulsion while serving as the communication center of Gateway. These elements are planned to launch in November 2024 using a SpaceX Falcon 9 Heavy launcher. They will be mounted with numerous scientific instruments, including NASA's Hermes, which will study space weather fluctuations caused by the Sun, and ESA's Ursa, which will study deep space radiation. In preparation for Gateway's first crewed entrance as part of Artemis 4, the station will be expanded with the addition of the IHAB. IHAB, which is being built by ESA and JAXA, has a diameter of 3.4 meters and length of 5.9 meters. It will provide additional living and working spaces, in addition to ports for docking with Orion and other elements. Sometime between Artemis 4 and 5, a SpaceX Dragon XL logistics module will then deliver Canadarm3, a Canadian-built 8.5-meter-long robotic arm system. It will inspect and repair Gateway, capture visiting vehicles, relocate modules, and help astronauts during spacewalks. Then, when Orion arrives with the Artemis 5 crew, it will deliver the ESA-built Esprit module. With a length of 6.4 meters and diameter of 4.6 meters, Esprit will provide hydrazine and xenon refueling for the Power and Propulsion element, in addition to a habitation area, more communications equipment, and storage. Finally, when Orion arrives with the Artemis 6 crew, it will deliver the last module, an airlock that will allow the crew to perform spacewalks. The fourth Artemis mission is planned to launch in 2027 and will include the first crewed entrance of Gateway. This time, the more powerful SLS Block 1B, launching from Mobile Launcher 2 at Kennedy Space Center, will send Orion and 4 astronauts, along with the IHAB module, into an Earth orbit, before performing a translunar injection burn. Once in lunar orbit, Orion will rendezvous with Gateway, where it will attach the IHAB module, allowing the crew to board the station. 2 of the crew will then board the docked Starship HLS and descend to the lunar surface for a multi-day mission. The Starship HLS will then return them to Gateway, where they will reunite with the other 2 crew, board Orion, and propel back towards Earth for re-entry and splashdown. The 5th Artemis mission is planned to launch in 2028. It will follow the same launch procedure as Artemis 4, but instead will deliver the Esprit module to Gateway. And once at Gateway, instead of using a Starship HLS, the crew will descend to the surface with a LETS lander. This lander will bring along NASA's Lunar Terrain Vehicle, an unpressurized rover that will drive astronauts around the surface. After another multi-day mission, the LETS lander will then return the astronauts to Gateway, where they will board Orion and propel back towards Earth for re-entry and splashdown. While Artemis 1 through 5 are the only planned missions so far, following missions have been proposed. Artemis 6, which would launch in 2029, would deliver the airlock module to Gateway while performing another crewed landing. Artemis 7, which would launch in 2030, would perform another lunar landing and would deliver the Habitable Mobility Platform, a large pressurized rover used for long-distance journeys of up to 45 days. Artemis 8 in 2031 would deliver the Lunar Surface Habitat, a permanent base camp that would support astronauts for longer duration stays. Artemis 9 in 2032 would deliver surface logistics, and Artemis 10 in 2033 would deliver more logistics, while performing a longer 180-day lunar visit. Finally, in 2034, Artemis 11 would deliver logistics and the first year-long lunar crew. At this point onwards, a permanent lunar presence would be established, with crews shifting every year. Over time, the Artemis base camp could be expanded into a full-fledged lunar village, using bricks and concrete made from lunar regolith. And eventually, everyday people could start to move in, setting up mining operations and kickstarting a lunar economy. By establishing a permanent human presence on the moon, Artemis will act as a stepping stone for crewed expeditions further into the solar system, most notably to Mars. The life support systems, human habitats, and technology needed to live on the harsh terrain of Mars will be tested and perfected on the moon. In addition, Artemis will provide the infrastructure for the deep space transport, a proposed spacecraft that would depart from Gateway towards Mars, where it would then orbit the Red Planet and support crewed landings. Then, once we establish a base on Mars, we can use it as a bridge to destinations even deeper into the solar system, helping transform humanity into a spacefaring civilization.